All right, let's dive into a classic statistical puzzle. You've got two groups of data, and you're staring at them, wondering, is the difference I'm seeing real, or is it just random noise? To figure that out, we're going to unpack three of the most essential tools in any analyst's kit: the independent t-test, the Welch t-test, and the Wilcoxon Rank-Sum Test. I mean, this is the core question, isn't it? It doesn't matter if you're working on clinical trials, marketing campaigns, or social science research. You're always comparing groups. Is this new drug better than the placebo? Did campaign A outperform campaign B? This simple question is the starting point for so many breakthroughs, but choosing the right statistical tool to answer it, that is absolutely everything. The best way to think about these tests is to picture a toolbox. You wouldn't use a giant sledgehammer to hang a small picture frame, right? It's the same idea here. You need to pick the right statistical tool for the job, one that's designed for the kind of data you actually have. Today, we're putting three of these specialized tools under the microscope. So first up, we have the original, the classic, the independent t-test. This one's been around since 1908, and it's kind of the gold standard. When it works, it gives you the most statistical power. But, and this is a big but, it only works under these perfect, almost laboratory-like conditions. Your data has to fall into that perfect bell-shaped curve, and the spread of the data, what we call variance, has to be almost identical in both of your groups. But let's be real. The real world is messy. Data is rarely perfect. And that's exactly where the Welch t-test comes into play. You can think of it as this really clever update that came along in 1947. Its superpower is handling groups that have unequal spreads. So if one of your groups has data that's all tightly clustered together and the other group's data is all over the map, the Welch t-test is specifically designed for that exact scenario. And finally, we have the Wilcoxon Rank-Sum Test. If the other two are precision instruments, this one is the rugged, all-terrain vehicle of our toolbox. It's a non-parametric test, which is just a fancy way of saying it pretty much throws that whole bell curve rule right out the window. If your data is lopsided or you have some crazy outliers, this test is often your most trustworthy option because it just doesn't play by the same strict rules. Okay, so we've got our three tools, but how in the world do you know which one to grab? Well, the secret is understanding the rules that each test plays by. In statistics, we call these assumptions. And believe me, getting this part right is probably the most critical step in this whole process. It really boils down to three big rules. First, there's independence. This just means the measurements in one group have no connection to the measurements in the other. Simple enough. Second, normality. That's our classic bell-shaped curve we keep talking about. And third, equal variances, which just means the data in both groups is spread out to about the same degree. Which test you end up choosing depends completely on which of these rules your data actually follows. And breaking these rules isn't trivial. It has serious consequences. This quote here points out a huge risk. Using the wrong test can inflate your type 1 error. So what on earth is that? Well, a type 1 error is basically a false positive. It's your test shouting, "Hey, you found something significant," when in reality, there's nothing there at all. It's a phantom discovery, and it's exactly what happens when you use the wrong tool for the job. Okay, here's where it all comes together visually. Take a look at this table. The independent t-test, right at the top, is the most demanding. It needs both normality and equal variances. It wants a yes in both columns. The Welch t-test gives you a bit more breathing room. It relaxes that equal variances rule. And then you've got the Wilcoxon test at the bottom, our most forgiving tool, which works even if you have a no for both. This table is basically your decision map. So here's the fundamental fork in the road you have to think about: the choice between parametric and non-parametric tests. The t-tests are called parametric because they make assumptions about your data's parameters, specifically that it fits that nice normal distribution. The Wilcoxon test, on the other hand, is non-parametric because it couldn't care less about the shape. It works by looking at the ranks of the data, not the exact values, and that's the secret to why it's so tough and reliable, even with really messy data. But listen, while some rules can be bent, there is one rule you absolutely, positively cannot break: independence. If your data points are related, like say you're measuring the same person before and after a treatment, then none of these tests are the right tool. Their entire mathematical foundation is built on the assumption that the two groups are completely separate. If you violate this, you compromise the results of every single test in this toolbox. No exceptions. Okay, enough with the theory. Let's get practical. How do you, as the analyst or the researcher staring at a spreadsheet, actually pick the right tool for your job? Well, it's actually a pretty straightforward process once you know what to look for. It really just comes down to this simple 3-step guide. Step 1, check for normality. Just look at your data. Does it have a rough bell shape? Step 2, check for equal variances. Is the data spread in both groups kind of similar? And then step 3 is the easy part. Based on your answers to those 2 questions, you just pick the matching tool from your toolbox. It's just a simple decision flowchart. So here it is. This is your go-to cheat sheet. If you've got that perfect, clean, textbook normal data with equal variances, then the independent t-test is your most powerful option. Go for it. If your data is normal but the spreads are all different, Welch's t-test is your new best friend. And for pretty much everything else, data that's skewed, data with a few crazy outliers, or even ordinal data, the Wilcoxon test is almost always going to be your most robust and reliable choice. Now, these 3 tests have been the bedrock of statistics for well over 70 years. They're legends. But science doesn't just stand still. Researchers are constantly cooking up new and even more powerful methods to handle the incredibly complex data we're all working with today. So, what's coming up on the horizon? Well, we're seeing the rise of really cool stuff like bootstrap methods and Bayesian approaches, which offer a ton more flexibility. And what I find even more exciting are these new adaptive or combined tests. These are basically smart tests that can integrate the strengths of both a t-test and a Wilcoxon test to give you a solid result no matter what your data looks like. They literally adapt to the situation. And that kind of brings us to our final thought for today. The independent t-test, Welch's, and the Wilcoxon are the absolute essentials that every analyst needs to master right now. But as our data gets more and more complex and these new methods become easier to use, you have to wonder, are we on the verge of a statistical revolution? Is the toolbox we just explored going to be replaced by a whole new set of smarter, more adaptive instruments? It's a pretty fascinating question for the future of data analysis. Thanks for joining me.